Okay, let's give you guys some practice. So somehow integrate this. So press pause and have a go. Okay, so to do this, complete the square on this. So completing the square would then take you to here. So now if you put this back into here, then this whole thing here would then become this. And then once you're here, create a triangle in such a way that this thing here will be true. Well, if you make the hypotenuse to be x minus 2, and if you make the adjacent to be 1, then the opposite will have no choice but to be this squared, take away this squared, and then square root the whole thing. So now we need to from our diagram we need to extract dx. So looking at this, so this is secant theta here. Secant theta equals hypotenuse divided by 1, which will then give you this. So now if you differentiate both sides, that will then give, if you differentiate this, that will then give you this. Differentiate this, which will be 1, because if you differentiate the 2, it will be 0. So if you differentiate this, it will just be 1, but then you've got x here, so it's dx. Now you've got your dx here. So later on we can put this whole thing into the dx. Now this square root complicated thing here, well, that's exactly the same as this. So if you consider tan theta equals opposite over adjacent, which would then be this. So now we can put this into here. Put this thing here into the dx. Then well, if you put tan into here, that will then give you this. And then if you put this whole thing into the dx, that will then give you this whole thing here. So now you've got tan, so that would be 10 squared. So that would be 10 squared, and then you've got your secant here. And then to integrate this, remember this diagram. If you consider a unit circle, and then consider this right angle triangle here, this is your tangent here. This is tan, this is secant. Well, secant squared equals 10 squared plus 1. Well, anyway, I'm expecting you to know this. So now we can, well, if you look at 10 squared here, so 10 squared equals secant squared minus 1. So we can put this into here. So that will then give us this. So now multiply this out. This times this, that will then give you this. This times this, that will then give you this. So now it's just a matter of integrating secant to the power 3 and integrating secant theta. So we've done this many times in the past. If you can't remember, look this up. If you integrate this, it will give you this whole thing here. It will give you this whole thing here without the bracket. Hang on, let me just erase this. Yeah. So now let me start again. If you integrate this, that will then give you this whole thing here. And then you've got your minus, and then if you integrate this, it will give you this whole thing here. So now if you look at this is exactly the same as this. So if you have half of something, take away the whole of that same thing, then it would be minus half. So it's just like me saying half of an elephant, take away one whole elephant. So it would be negative half of an elephant. So that will then take us to here. But then we don't want the answer in terms of theta. We don't want the answer in terms of tan theta. So we've got to go back to our original triangle, which was this thing here. Going back to our original triangle, now translate everything. Secant theta would be this. So that would be x minus 2 over 1, which will be this thing here. So you've got your half here, and then what is tan theta? Tan theta, hang on, tan theta would be this thing here. So that would be opposite over adjacent, which is this thing here. And then you've got negative, negative, half, half, natural log, apps, and then you've got your secant theta. Secant theta is this thing here, which is x minus 2, and then tan theta is this thing here, which is this thing here. So this here is your final answer. Okay.